We're the open source Beehives project, and we would like to share with you some notes on a collaborative response to an ecological crisis.
So I'm Jonathan Minchin. I'm coming from the Barcelona Fab Lab and working in particularly at the Green Fab Lab just outside Barcelona in the Collserola.
And my name is Tristan Copley-Smith. I've been working with an open hardware company called the Open Tech Collaborative based in Denver, Colorado.
So we are a group of makers primarily, beekeepers also, community builders, and in a sense, a multitude of different disciplines coming together.
So the Open Tech Collaborative has 40 acres of land in Denver, Colorado. So it's about 10 minutes north of downtown Denver. So it's very close to a city center.
And the Green Fab Lab, part of the EAC school, has 140 hectares of land. So we're interested in projects that connect back to the land or that use the land. So in both spaces, it's interesting for us to host these guys. So these are our clients, in a way. And these are standard European honeybees, which, of course, are very much in the news at the moment and are under threat, extreme depletion of bees.
Maybe a show of hands. How many people have heard about the bee issue? Okay,
That's
quite a lot of
everyone.
people. So yeah, the PR campaign's been pretty effective to show that there's an issue out there. So we're responding to that.
So in many ways, part of the problem, I think, is the way we keep bees. So this is industrial agriculture or industrial apiculture, where you could have 1,000 hives in one place at one time. So that's very good for our agricultural system, but perhaps a little more problematic for the bees themselves.
In fact, many areas of our agricultural system need the bees in order to pollinate extensive crops. And this is a problem for bees because monocultures, which are single crop cultures, deplete bees of the diversity and the minerals that they need to be healthy and thrive. So that's one of numerous stress factors that are causing problems for bees and potentially the reasons that they've been disappearing.
Okay, so we're interested in alternative models. So if we're talking about agriculture and the agricultural industry, we could also talk about backyard beekeeping, local beekeeping, or apiculture on a smaller scale. So we're much more interested in developing beehives, developing best practices, and working with ecologists that are targeting the small scale.
So one of the issues has been an ongoing issue that we talk about a lot at places like WeShare is centralization not necessarily being the best way of doing things. So an example of centralization in beekeeping is a single beekeeper keeping 20,000 hives as opposed to 20,000 people keeping a single hive. The problems with this are the spread of diseases is catalyzed, and problems are kind of exacerbated by the fact you've got so many in single small spaces.
There's also the fact that if you have 20,000 people working with beekeeping, or with any other subject for that matter, you have a variegation in knowledge and expertise, experimentation and innovation. So with that community and that difference, we can start to innovate faster and do so in a collaborative way. So this is very much a long tradition of beekeeping and hive building that we're working with. So we're very happy to be here in France and in Paris. One of the hives we're working with is by Abbé Waré, who did a very similar thing. He created what he called the People's Hive, which could be considered the first truly open source beehive, and tested around 350 hives himself to create a model that could be taken up by the French beekeepers. He did this in response to the decline of beekeeping in France at the time.
So this is the Kenyan top bar hive, which was developed originally in Kenya, surprisingly. And it's championed currently by a modern-day beekeeper called Phil Chandler, who's a deep believer in the naturalistic forms of beekeeping, whereby you don't put frames in the hive, which basically dictate the cell size of your honeycomb and thus the size of your bees. And they're often made out of industrial waxes and plastics. Instead, the bees are able to build their own comb naturally on things called top bars, which sit along the top of the hive. So we're embracing that similar form in our designs as well.
This is both of the hives, in this sense, as Tristan says, the natural beekeeping methodology that is suited more to backyard or individuals who want to interact with the hive one by one. So they're designed not for industry, but for individual practitioners. And they very much just let the bees do what they would do naturally.
So these are our two hive designs. On the left, you see our version of the Kenyan top bar, which we've called the Colorado top bar. On the right-hand side, you see the Barcelona Ware, which is John's brainchild. Over in Denver, we've been working on the Colorado top bar. And the interesting thing that makes these hives most accessible to people is that essentially you can download the files we've put on our website for free. You can download them, take them to a CNC workshop, plug them into a computer numerically controlled router machine, which are increasingly accessible at lower cost. And from a single sheet of plywood, you can route out in approximately 40 minutes the Colorado top bar. The Ware is a little longer, but from a single sheet of plywood, 40 minutes, you cut it out, you take the pieces off the router machine, and you can stick them together without any screws or glues. They just all fasten together with lock mechanisms that we've designed.
So these are some of the images of the hives in various stages. We've gone through lots of iterations of the hives and continue to do so. So these are the hives in real life. A lot of this is more about listening to the communities and bringing back their knowledge into the design. So we've done a lot of research and a lot of listening to different types of people. And that's really what this is about.
So the focus has been majoritively recognizing these four factors, which is citizen science, which is a growing trend of citizens working together to solve problems. A global problem, which is the ecological problem in beekeeping. Recognizing that there's an existing community of people who have pre-existing knowledge, beekeepers, makers, concerned citizens wanting to act upon it, and technology was a common interest between John's organization and our own in Colorado. So those were the kind of binding factors we recognized.
So within this set of different groups and different kind of world views as well, if you imagine we are makers primarily and working with technology, but there's very different perspectives that are coming from the beekeeping community and also from the scientific community. So it's interesting for us within this project in the longer term goals to work out some protocols of common language to be able to bridge those divides. So some of these principles are to be open, of course, but to promote best practices of all of the work that's generated, not just our designs, but the designs that come back to us. To embrace those different communities and encourage makers, beekeepers, scientists to try and bridge the gap themselves.
So additionally, we're trying to listen to the community. And this is a really tricky one because often the community doesn't tell you what you want to hear, which is usually, oh, this project's amazing, you guys are great, there's nothing wrong with it. There's always something wrong and someone's always going to point it out, and you've got to actually make a real effort to listen and hear them and not take it personally. I ended up taking it personally and I lost hair, so hair on my head, I've got gray hairs now, so just try and listen and absorb it and take it constructively. The other thing is to cultivate a fun, productive team environment. So that's what we did. We were disparate in the sense of geographically for a lot of the time. This is the first time I've seen John in person for many months. And as long as you are creating an environment where you're enjoying each other's company, you're more productive and you don't see the project as a burden, you see it as a pleasure. Also, sharing resources, be they financial or otherwise, and recognition with collaborators is something very important. You don't want to centralize, once again, you don't want to centralize any of the recognition, you want to disperse it to those who've helped you achieve your goals. So that's another important thing.
So to facilitate some of this conversation between the different groups that we're working with, we've opened up a forum. We've got something like 1,200 comments and talks on different conversations of different topics, from sensors to the design to best practices and just to the bees themselves. So it's a very difficult thing to manage, and I just want to add that Tristan's been very brave and active to dive into unknown environments on this forum.
Particularly the Reddit beekeeping forum, they're pretty mean in there.
So other kind of protocols and platforms that allow for this collaboration is not just about knowledge transfer or sharing views or sharing information. It's the designs themselves. So we're using Github here to be able to open the designs up so people can download them, so people can upload them again, and we can track all of the changes and tie those back to the knowledge we've gained. So in this way, we can produce our own designs, our own documentation, and send that out to the community. We've been working with different file types that we know work with open source software and could be transferred very easily. This is just an image of what it looks like to design a beehive in a flat pack and then send it to a CNC machine.
So one of the funner parts, I guess, of the project was designing these instructional manuals, and John did a great job taking the design files and turning them into these beautiful kind of images that we can show people easily how to assemble, and people without experience give them advice on how they might get them routed themselves with a relatively complex machine. Also a beekeeping course, a crash course in beekeeping, which was interesting to write.
So these are just the hives being constructed at the moment for the backers of a crowdfunding campaign, and we're sending these off to those people at the moment. But every backer would get this download kit to be able to engage with the work themselves.
We've had a number of remote replicators now around the world, as you can see here. Interestingly, we started the project out of season with beekeeping, so obviously it's a seasonal pursuit. You start putting new bees into hives in spring. We were developing the project through November, so coming to the end of that season. So what we did is, as you can see, there's some collaborators in the Southern Hemisphere, other fab labs we contacted in Lima, South Africa, and New Zealand, who helped us develop the design through the non-conventional seasons.
These are some of the images we're getting back from the people who have received the files. One in particular is interesting, where they've made the hives out of solid pine. And the board wasn't big enough for the machine. So they've cut the front legs in half and then created a new locking system to be able to bring that back together. So we appreciate these kind of the feedback, whether it's technical or on beekeeping itself. So I think the crux of the matter, just as we're running out of time, is about monitoring. So in a second phase of this project, yes, we've constructed beehives and we've in some way managed to generate a community. This is about monitoring and really understanding the data and the information that can be brought out of a hive.
Relevant to the disappearance of bees. So we're trying to figure out why it's happening and using crowdsourced information via citizens to figure that out.
So we're working with some of these groups now to be able to, most of these are institutions from the scientific community that can deal with the data that we're producing. So this comes back again to the Smart Citizen project, which Thomas Diez here has brought forward. The very interesting thing about the Smart Citizen is it allows us to work on the different types of sensors that we need for beekeeping, and to just literally fit that on top of the adapted Arduino that the Smart Citizen team have created. So this technology is very useful for people like us who would like to work in a particular direction.
Additionally, we're modifying the sensor board so it's detecting things relevant to bee health, including humidity, temperature, ambient noise, specific frequencies, weight, pesticide detection, which is really important, and electromagnetic fields.
This is an image of the Smart Citizen, so all of that data that we're producing, we hope to be able to put through the API as an open service through the Smart Citizen platform and publicize that data as a citizen investigation also.
So yeah, recently we just finished a crowdfunding campaign. We weren't sure exactly what the community response was going to be in this area, but we were really blown away. We ended with 71,000 views, over 1,000 backers. We sold 50 of the pre-made hives and 1,000 of the download kits. So this is an ongoing project, and we hope to see a lot more people who've downloaded the files print out their own hives or route out their own hives. John hates it when I say print because it's not printing. And we funded ourselves 315%, so we aimed for 20,000. We actually ended up with $63,057. So that's all going into sensor development and community building and continuingly iterating improvements on the project.
So I think this is I think the points that we'd really like to make is that this is work that brings together ecologists, makers, thinkers, and real scientists, the people who are investigating at a deeper level. And through this campaign, we really hope to work and bring those communities together in the future. Thank you very much.